Welcome back to our channel. Today, we're diving deep into one of the most mysterious and powerful phenomena on our planet. Have you ever wondered what happens when volcanoes erupt underwater? Buckle up, because we're about to explore the explosive world of submarine volcanoes. We all know that volcanic eruptions on land can be quite devastating, but what about large volcanoes erupting under the sea? Imagine, deep beneath the ocean's surface, a hidden giant awakens. An underwater volcano starts to rumble, sending vibrations through the water and stirring up the ocean floor. But what exactly happens when a volcano erupts under the sea, and how does it impact our world? First, let's understand the basics. Underwater volcanoes, also known as submarine volcanoes, are found on the ocean floor. These geological wonders are similar to their land-based counterparts, but operate in a unique environment. When they erupt, the interaction between molten lava and seawater creates a spectacular and sometimes violent display. The eruption of an underwater volcano starts with the movement of tectonic plates. These plates can either pull apart or collide, allowing magma from the Earth's mantle to rise to the ocean floor. The pressure builds until it finds a way to escape, resulting in an eruption. When the magma comes into contact with the cold ocean water, it cools rapidly, causing it to fragment into small particles. This process can create explosive steam blasts, sending plumes of ash and volcanic gases into the water. Unlike land eruptions, these underwater blasts can be somewhat muffled by the surrounding water, but they are no less powerful. Now, let's look at a couple of examples to illustrate this phenomenon. One notable underwater volcano is the Axial Seamount, located about 480 kilometers off the coast of Oregon, USA. This volcano is one of the most active underwater volcanoes in the world. When Axial Seamount erupts, it creates hydrothermal vents that release mineral-rich water, supporting unique ecosystems. These vents are home to creatures like tube worms and giant clams, which thrive in conditions we would consider extreme. Another example is Kikumjeni, located about 8 kilometers off the northern coast of Grenada in the Caribbean Sea. Since its discovery in 1939, it has erupted more than a dozen times. One of the biggest concerns with Kikumjeni is the potential for tsunamis. An explosive eruption could displace a large volume of water, generating tsunamis that could impact nearby islands and coastal areas. But what about the impacts of these eruptions? When a submarine volcano erupts, it can have several significant consequences. One major consequence is the formation of new land. Over time, continuous eruptions can build up layers of lava, eventually creating new islands or seamounts. This process gives us a fascinating glimpse into how volcanic islands are formed. Eruptions also create hydrothermal vents. These vents release mineral-rich water, which supports unique ecosystems that rely on chemosynthesis instead of photosynthesis. This means life can thrive in complete darkness, relying on the chemicals spewed by the vents rather than sunlight. However, underwater eruptions can also be dangerous. The explosive interaction between magma and seawater can generate tsunamis. These massive waves can travel vast distances, posing a threat to coastal communities far away from the eruption site. Additionally, the release of volcanic gases like sulfur dioxide can alter the chemistry of the ocean water, impacting marine life. One of the most devastating underwater eruptions in history occurred in 1883 with the eruption of Krakatoa in Indonesia. While Krakatoa itself is a volcanic island, much of its eruptive force was underwater. The eruption caused a series of massive tsunamis that devastated the surrounding coastal regions, killing over 36,000 people. The tsunamis were so powerful that they were recorded as far away as South Africa. The eruption also had a significant impact on the global climate. The massive amounts of ash and sulfur dioxide released into the atmosphere caused temperatures to drop worldwide. This led to spectacular sunsets and a period of global cooling that lasted for several years. So how do scientists monitor and study these underwater volcanoes? Given their inaccessible locations, it's a challenging task, but we have some fascinating tools at our disposal. Seismic monitoring is one key method. Sensors placed on the ocean floor detect seismic activity associated with volcanic eruptions, providing early warning signs and data for research. Remotely operated vehicles, or ROVs, and manned submersibles allow scientists to explore and study underwater volcanoes up close. These high-tech tools can withstand the extreme conditions of the deep ocean and send back invaluable data and images. Satellite imagery also plays a crucial role. Satellites can detect changes in the ocean's surface and thermal anomalies, helping scientists track volcanic activity from space. Finally, oceanographic surveys conducted by ships equipped with sonar and other instruments map the ocean floor and monitor volcanic activity, providing a detailed picture of these hidden giants. To sum up, underwater volcanoes are powerful and mysterious features of our planet. From creating new land to supporting unique ecosystems, their impact is profound. By studying these submarine volcanoes, we not only learn more about our planet's geology, but also about the resilience of life in extreme environments. Thanks for joining us on this deep dive into the world of underwater volcanoes. If you enjoyed this video, give it a thumbs up and don't forget to subscribe to our channel for more exciting explorations of our planet's most intriguing phenomena.